All right, beautiful people. So yesterday we talked about writing numerical expressions from a story problem, and today our essential question is how do we write an algebraic expression from a story problem? And in all honesty, they're very, very similar. The only difference is we're going to note that algebraic expressions have variables, contain variables, okay? So when they give you algebraic expressions with variables, sometimes they'll give you the solution of the variable and sometimes they won't. So for these examples, they're not going to give you solutions to the variables. So we're just going to write the expression and that's it. We can't solve it. There's no more simplifying than just writing the expression. So I'm going to start with our first example. Okay, our first example is 14 more than a number x. If we look back at our notes from yesterday, we can look in our table and see what this term more than stands for. Okay, so in our table, we look for the words more than, and we find that more than means addition. More than is addition. Okay, so I know that I'm going to have addition. Okay, but remember from yesterday when we talked about the word than, and how than changes the order. I'm going to write it again. Than changes the order, okay? Because it basically says the first number is this number x. So we'll start with x plus 14 because it's more than x. So if I start with x and I add 14 to it, I will get that final number. And then this is as far as we can go because we don't know what the value of x is. So this is our expression, x plus 14. That's it. That's all we've got. Until we have a value to plug in for x, this is as far as we can write. Okay? All right. So I'm going to write another expression. Okay, so the second expression is a number y minus 75. So again, we're looking at the word that's in there that tells us the operation, and it says minus. Okay, so if I look back at the table from yesterday, minus means subtraction. Okay, so we're going to put subtraction. And this expression does not have the word than or the word from. So the order stays the same. So I start with y and I subtract 75. Okay. An incorrect answer would have 75 first. This is going to stay in the exact same order it was written. The only time you change the order is when you have the word than. Okay. All right, so then again, just like the last time, because it has a variable and we don't know the value of the variable, we can't do anything else. So let's try another example. Okay, this example says the quotient of 3 and a number z. So I've got a word in there that tells me the operation, and that word is quotient of. So I've got to look in the table from yesterday. So flip back to your notes from yesterday and look in the table. Quotient means what operation? It means division. Okay. So again, it doesn't have the word than or the word from, so we keep it in the exact same order it appears. So 3 comes first, and it's divided by z, whatever z is. And that's my final expression, okay? All right, I'm going to give you 2 triads. Okay, so the 2 triads you get are 25 less than a number b, and the total of a number t and 11. So 25 less than a number b and the total of a number t and 11. Pause the video. Try them on your own. Okay, hopefully you've come back by now and you're ready to go it over. So the keywords in this first one, 25 less than a number b, is less than. So I know that less than means subtract. Okay, so I know I'm going to have subtraction. But hey, just like in that first example problem I gave you, this one has the word than, which means we switch the order. So b goes first. So we start with b and subtract 25. This should be your answer. Okay. All right, the second one says the total of a number t and 11. And total, if I look in that table, means to add. So it doesn't say than or anything, so I keep it the same order, and I do t plus 11. Nice job.